For question 21, it is a very interesting question, a logical deduction question, I can say. So the numbers represents the number of red cells there are in each row and column, which means that if there's no red cells in this column, it is 0. If there is one red cell, it is 1. If there are two red cells, it is 2, something like that. So which of the following tables could Carl have created? So first of all, if you look at A, you can see that this column is 0, which means that there's no red cells there. But this row is full, which means that all of them are red cells. That is in contradiction with the 0 column, so A cannot be the answer. As for B, well, you can see that for the total number of cells, each cell should be in one row and one column, right? But then for B, you can see that the rows add up to 1, 2, 1, 3, that's going to be 7. The columns add up to 2, 2, 3, 1, that's going to be 8, which is not matching. So it is impossible because there can't be a cell that is in a column but not a row, right? And as for C, why is it impossible? That's because we have 2 rows of zeros, which means that there can't be any red cells in these 2 rows. However, we have a 3 in the column, which means that apart from these 2, either one of them has to be a red cell as well. So that is impossible. We eliminate C. As for D, 2, 1, 2, 2, 2, 1, 2, 2, it seems fine for me. So let's leave it here for now. And for the last one, 0, 3, 1, 3, 0, 3, 3, 1. So let's see if there's anything that is unreasonable there. So if I have 0 in the column, 0 in that row, and then 3 of them all booked in, because I need to fit the zeros, you can see that this cannot possibly be a 1, right? Because I need all these to be filled in to satisfy the 3s. Otherwise, I would be conflicting with the 0. So in the end, if I'm satisfying the 3, it doesn't satisfy the 1. So this is also contradicting. So finally, D has to be correct. If you don't believe me, you can try it out. Well, 1, 1, let's shade this box. And then 2, 2, so probably I'll do this one. Probably I'll do this one, such that I can have a bit of options there. And then I can do this one, and I can do this one, and I can do this one. Something like that. Is that fitting? 2, 1, 2, 2, 2, 1, 2, 2. Yeah. So I think there will be more options than this, but this is one of the ways that we can do it. All right. As for question 22, so this is purely numerical for this kind of number array problems. So 1 to 7 are the numbers that Andrew is putting in. Which number should he write in the top circle? So first of all, the numbers would be counted like that, right? So you can see that except the top one that has been counted 3 times. This is in 2 lines, 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 this is in 2 lines. Which means that I am counting every number twice, but the top circle 3 times. Does it make sense? So it means that the sum of all the numbers should be 2 times of everything, 1 adding up to 7. That's 28. So 2 times of 28 adding the top cell is 1, 2, 3, 4, 5 lines. Which means that 56 adding T is 5 lines, the sum of 5 lines, which is a multiple of 5. So it means that T has to be 4, or T has to be 9, which is impossible because we don't have a 9 in the list. So T has to be 4 as the answer. T means the top number. And then for question number 23, this one is very interesting. So if you fold it twice, what is the sum of the areas of the two shaded rectangles? How do you find the area of the shaded rectangles? First of all, you need to know what are the dimensions that are taken. So this, if this is folded half there, it means that this is going to be halving the length of the side, right? So this is 4 and 4, 4 and 4. And then if the other side is folding along this line, what does it mean? It means that, well, if you're trying to imagine half of this length between here and here, we need to cut it into smaller pieces. So probably we can just try to do it like that, give it an extra cut, such that now you can see that it has been splitted into it has been split into some clear sections now. So I can see that this is going to be a 6 by 6 square there, right? A 6 by 6 square. So this has a length of 6 and 6 and 6 and 6. And I'm just trying to fold it up right here to halve it, right? So you're going to just imagine that this is just right here. And after folding it, what we have left will be the two sections right here. These are the sections that are unaffected by the two foldings. So now it is cut into 16 pieces, and the two rectangles are taking 4 of them. So we have 64 divided by 16 times 4, which is a quarter of 64, and that's going to be 16. All right. And then this question 24 is pretty easy. So it says that the digits PQR are used to make the 3-digit number PQR, 2-digit number QR, and 1-digit number R. So it means that I have PQR, QR, and R together. So the sum of these is 912. What is Q? It's pretty easy. We just have 100p, adding 20Q, adding 3R is 912. So the 2 must come from 3R, right? Because otherwise 20Q and 100p will end with a 0. So it means that R is 4 because it's a single digit, so it's the only possibility. Then we have 100p adding 20Q is 900 because 3 times 4 is 12. So it means that 10p adding 2Q is 90. Now, what it means is that Q has to be a multiple of 5 for 2 times Q to be ending with a 0. So because Q is a non-zero digit, it cannot be 10, it cannot be 0, so it has to be 5. So we have the value of Q. Q is 5. All right?